I'm Justin, and today I'm going to talk about Transport-SDN network and the use cases in Korea. And use cases here refer to OpenDaylight use cases, and they don't mean they are in production, deployed yet. But I hope they will be in production in a very foreseeable future. Okay, so without further ado, let's get started. This outline shows you the things that I will cover today. I will introduce our team and team members, and then I'm going to give you some background on what transport networks are, and then I'm going to give you the problem that we've been tackling for a year and a half, and then we're going to give you some reasons why we chose OpenDaylight specifically to solve this difficult issue. And then I'm going to show you our architectural details as well as implementation details. And then I will introduce you to some OpenDaylight use cases by Korean carriers. And I'm going to point you to some key takeaways. And I will share our future plans with you. And if still we have some time left, I'm going to have some Q&A session. Okay, who we are. Our institution is called ETRI. It's pronounced ETRI, and it has 40 years of history in computer networks. But I'm not going to go into details about that. But we all work for ETRI, and let me just start with our team member, team leader, Dr. Park, and he has 20 plus years of experience in computer networking. And he has also worked for a carrier company called Telecom back in the days. And we have our modeler, Chang-Gil Lim, and his nickname is Human. And he has 15 plus years of experience in optical and transport network. And he did all the modeling for our Transport-SDN controller. So he's the go-to guy when I have problems with understanding networks. And we have Dr. Shin in the audience, and he has done almost the half of the implementation of Transport-SDN controller that we are using right now. And we have Tae-Hong Kim. He left us this year, but we still collaborate in clustering our transport network SDN controller. And we have RMJ. He's a computer geek, and he's your neighborhood hacker. So he's even better than PhD in computer science. He's still undergrad, but he's the go-to guy if I have issues with programming. And lastly, but not least, that's me, Justin, and I have 6 plus years in computer networking. And I started with Future Internet, and then I dabbled in OpenFlow controller developing. And I've been working on Transport-SDN for about a year and a half now. So if you're like me, I didn't know about transport network 2 years ago, but I've been working on it a year and a half now. So this is for the beginners. I think transport networks are logical circuit networks, and they provide QoS, and it's frequently used by carriers. When I first heard the term transport network, I thought it was similar to ATM networks, something that exists only on textbooks. But they are frequently used by carriers and network operators. So, and one of the representatives protocols for transport network is SONET-SDH, and it provides fault detection. It's called OAM, and fast protection. It's sub 50 millisecond protection, and it also provides end-to-end QoS. So the domain is really different from IP networks. Transport networks carry IP packets, but they don't do IP forwarding, but they do forwarding based on labels or lambdas in OTN or in optical networks. So OTN is basically a direct successor to SONET-SDH with wavelength switching capability and more bandwidth. And MPLS-TP is dealing these issues, OAM protection and QoS, in packet technology domain. So there are other examples like PBBTE, but MPLS-TP is most frequently used by carriers in Korea. So what's the problem that we are trying to solve here? We've been talking to carriers in Korea, SK Telecom and Korea Telecom. That stands for KT and SKT. And they've been complaining to us. They have issues of vendor lock-in. They were afraid of vendor lock-in, so they bought devices from many different vendors. And what they ended up is these EMSs can control devices from other vendors. And this lack of compatibility issue. And when there's a network across multiple vendor domains, and there's a path, and that path is set by a human operator, and the human operator uses many EMSs to set one path, and they don't want to change that path because it's really complex. So they just want it to stay that way, but that brings to the lack of agility. And bringing another device from another vendor is complex. They don't want to even think about it. So that's lack of scalability. So these are the issues that we are trying to tackle for a year and a half. So telcos in Korea want their operational simplicity back in their network. That basically means they want a Transport-SDN controller that can control multiple domain EMSs or multiple domain devices or multi-level devices. And once they have that TSDN controller, they can control multiple vendor domains, then they can provide differentiated service delivery. And they will have their scalability back in their transport network. And they have their legacy interoperability and multi-domain internetworking back to their network. That's what they want. So we are trying to solve this issue, and we chose OpenDaylight because there are many reasons. But I can think of three top reasons why we chose OpenDaylight. There's a Yinyang model, and Yinyang provides excellent separation between modeling and implementation. Have you guys ever heard about MVC model number 1 and MVC model number 2? If you are developers, I'm sure you are aware of that. In MVC model number 1, they have Java implementation for modeling, and they have servlet. It's also Java implementation. So they had difficulties in working with designers and programmers working together. It was really difficult because designers couldn't understand Java implementations. So they invent JSP, and they call it MVC model number 2. So after inventing JSP, they had much easier learning curve for designers, and they could work with programmers with much more ease. And I believe Yinyang does the same thing for network experts and programmers. People outside of this room think network experts and computer programmers are the same people. But people inside of this room all know they are really different. And I know there are many wonderful computer network experts, and there are great programmers. But there aren't many people, as I know, who know the both world. They are like precious gems. So it's really nice. It's really wonderful if people can work together. If they have Yinyang model, it really ease the learning curve for the network experts to work with programmers. And MDCell, it enforces the Yinyang models to implementation. And I'm not going to go into details about MDCell because there are many sessions dealing with functions of MDCell. But I want to mention routed RPC because it significantly eases bringing new plugin by decoupling RPCs from plugins. What that means is, if you have new plugin for new vendor, without routed RPC, you have to change your source code in the controller. But with routed RPC, the RPC is routed in runtime. So you don't have to worry about changing your manager or controller code. You can just route it with this node reference information. So this is really make our solution graceful, and this makes these all tools. We can really leverage these tools in making our solution much better than it could have been maybe 5-10 years ago. So this issue, multi-vendor issue, is not a new issue. It's been, at least I know, it's been 14 to 15 years. But they've been trying to solve this issue for a long time, but they couldn't. I think it's because, do you guys know about PDAs back in the days? We had PDAs, right? PDAs, they were really similar to smartphones we have today. But it wasn't, PDAs weren't very successful because I believe the technology wasn't ripe. And I think it's the same for the multi-vendor issues as well. Now we have ODL. I'm not just saying this because this is ODL Summit, but I believe now we have the technology and the tools ready in solving this problem, multi-vendor problem, gracefully. So let me go to the architecture. If I have to pick just one slide out of all the slides that I have prepared, this is the single most important slide that I have. And it explains how Transport-SDN works. So let me start with EMS over here. This EMS is connected to multiple nodes or multiple devices. And it extracts the information up to the EMS plugin. And then this EMS maps all the information to the notification defined in the Yinyang model. And it sends the notification to the MD cell, and inventory manager reads the data and stores in the data store. And topology manager and service manager, they register their listeners to the inventory manager, and they make changes. When there's changes, it notifies it. So they make changes in accordance with their needs. And when that's done, the operator can see what's in their network, what resources are available. They can see the nodes, topology, links, nodes, node connectors, and etc. And the human operator, think about service. Think of service. Service maybe pseudo wire service across vendor A to vendor C. And he inputs it, makes the service input, and calls this RPC called create service through the REST-conf. And service manager understands and parses this service input into multiple RPC calls. For example, if there was just one service creation input, it makes maybe 2 create access interface, 2 tunnels, 2 tunnel XC, tunnel across, and 1 pseudo wire, something like this. It makes multiple calls to plugins. And then the plugins can use their specific EMS command to make whatever changes necessary in their networks. And when it's done, they report it back to the plugin, and they make notifications and let the operator know if their service creation command was successful. That's basically how it's done. So let me explain how we model our Transport-SDN network. I'm not the modeler, Yinyang modeler, but I was beside him and I saw how he did it, and this is basically how he did it. So first of all, you extract common idea between optical OTN and MPLS-TP. Something like node connector, access interface, inventory, port type, it's all common. And you have to think about the differences between the OTN and MPLS-TP. OTN specific things like tri-bit slots, ODU 0, ODU 1, 2, 3, 4, those are specific to OTNs. And you think about the specific things about MPLS-TP. I can think of MPLS interface and pseudo wire and things like that. It all goes into data model, and then you have to think about RPCs. RPCs, like set access interface, you can think of it like create access interface, create MPLS interface, create tunnel XSC, create pseudo wire, etc. And you think of notification. It can be something like tunnel updated, pseudo wire updated, MPLS interface updated or removed, and things like that. And this is, just for a side note, this is actual Yinyang models that we have developed. And this figure is similar to this, but have different perspective. It focuses on data store, and if there's notification, if there's one node detected by EMS, then it puts another node here. If it detects another node connector, it puts here. And if it's removed, it removes from the data store. And the basic idea is the same from this picture. And this is the real development setting that I'm using right now. And this is, I'm creating a service. This is the service input. And it goes all the way from here, all the way down there. And what it reports back is, this is the capture from API docs. And I can see the node details. There are 3 nodes, and there is a created access interface, and there are tunnels created. So this is basically how it's done. And this is a test bed we have used in 2015. This device here is our POTN device. And these devices are from Telefield, Coweaver, URINet, and they are the vendors work for SK Telecom. And we envisioned making this network controlled by single transport network. And what we ended up is a little bit less than that, I'll be honest here. We were successful in bringing these two, ETRI's network, ETRI vendor, and the URINet devices, and we were able to control and make access interface and make 2 tunnels, make working paths, protection paths, and we were able to send 7 gig video data across from here to there. And we were able to make multiple services and delete those services as we want. That's what we've done in the winter of 2015. And we've done a lot more this year, and I hope I get to show that maybe next year. And I'm going to briefly mention some use cases in Korea. So we've been working with SKT and KT. So this figure is what we got from SKT directly. And this is very similar to the picture that we have because we've been collaborating and we are getting the requirements from SK Telecom. So the figure is really similar and they want to control their POTN devices with their TSDN controller. And somehow they have 2-tier design, but I think that we should talk to them about 2-tier, 3-tier. It can have recursive design or whatever as necessary. And KT also has their network. And if you can see, there is a inventory manager and service manager, and the architecture is really similar because we are cooperating with KT as well. And they are working on PTN and MSPP and OXC device in their network. So let's go to key takeaways. I've explained the big picture of how SDN controller works. And it could take weeks or months just thinking about this workflow that I have explained. And you could be still wrong. But with this picture that I just showed you, it's not wrong. It works. We proved it already. So you have to, if you want to apply this TSDN technology into your system, maybe you can think about the procedures that I just explained before and make changes, necessary changes to it. And now you can think about how to design Yinyang models for Transport-SDN. Yeah, I briefly mentioned, but you can start to think about it. And I think Yinyang modelers should think of programmers and developers as their customers and really leverage object-oriented programming design into their Yinyang model. So the programmers can really make their code more efficient. And you also have to check for your compatibility issues. Even if you use the same protocol, let's say it's MPLS-TP, we had some issues with MPLS-TP OAM frames and pre-processing. So for that reason, it was incompatible. And we have to make some changes to the driver. And I heard that we had some difficulties in OTN 100G. I heard there are some standard issues. So I think those three are key takeaways from this talk. And let me share our future plans. We are going to upgrade our Yinyang models, reflecting what we've learned so far this next year. And we will provide a southbound plugin architecture for many nodes. Now we haven't had a chance to thought about plugin architecture for many nodes. I'm talking about like 1,000 nodes and more. And we want to incorporate more vendors. And we want to expand more protocols. We are already working on OTN. And we also want to expand to ROADM and more. And we want technical cooperation with members of ODL. And that's about it. Thank you. If you guys have any questions, yeah, I can take one or two. Yes?
So you understand you deployed controller game for OTN, but you ever think so-called deploying also it for WGN?
What's that again? Can you repeat your question?
So you are currently driving a device with OTN support?
Yeah, we are working on OTN, and yeah.
Have you tried to also driving the WGN layer with it?
We are working on OTN, and there's POTN device in ETRI. So we are using that to work on our MPLS-TP and OTN. We are working on it simultaneously right now, to be more exact.
I think I was asking about WDM.
We haven't started working on WDM or ROADM just yet. And we are thinking about it maybe next year. Yep.
Are your Yinyang models public, by the way?
Yinyang model what?
Are you releasing your Yinyang models in some public site?
We not yet, but we made a project on ODL. It's called POTN. So we have plans to open our source code, not just the source code, but Yinyang model as well. Okay.
So, have you looked at the Yinyang models for transport APIs developed by ONF?
ONF?
And that includes actually L0 to L3 common models.
Okay.
OTN.
Yeah, I haven't because I do the implementation, but our Yinyang modeler has already looked at it, and yeah, he's gonna make necessary changes next year. Okay, thank you. Okay, thank you.